Hi, my name is Charlie, and you can also call me the guitar boy. Today we are going to be doing chemistry, and we are still on the topic of atomic structure. This is atomic structure 4. I decided to name it 1, 2, 3, 4, 5, 6 in order to connect the topic together. We cannot just treat them under one video, so we have to break it down in order for us to touch the important aspect of it. So in our last class, we talked about the person that discovered electron, and we said it was J.J. Thomson that discovered electron using a discharge tube and passing a high PD across the discharge tube at a low pressure. So we discussed that. If you have not watched that video, go and watch that particular video on the discovery of electron. Today we are going to be talking about under atomic structure, talking about the discovery of proton, and also talk about Rutherford's model of an atom. When you hear model here, it means, okay, after maybe Rutherford has carried out his experiment about an atom, what does Rutherford now tell us that an atom is now? Okay, you have carried out your experiment. Tell us what an atom is now. So tell us your model of an atom. What Rutherford would now eventually tell us that an atom is Rutherford's model of an atom. So we are going to talk about this now, talk about the discovery first before we talk about its model of an atom. Now, in order to know what is inside an atom, Giga and Marsden Rutherford's boys. So the two of them were Rutherford's boys. So what they did was that they bombarded a tin gold foil with a narrow beam of alpha particle. They bombarded a tin gold foil with a narrow beam of alpha particle. And in order to know what will happen as they bombard it, they placed a movable zinc sulfide screen attached to it, which was a microscope. The microscope was attached to that zinc sulfide screen in order to know what will be happening around the bombarded gold sheet. So as the screen move around, there will be something, at least it will be help us to notice what is happening around the bombarded gold foil. That is the essence of the screen and the microscope. To let me draw on the board to make it clear what I have just talked about the work of Giga and Marsden under the instruction of their master Rutherford. In that experiment, they have a lead container. In this lead container, it has a radioactive substance so that the substance will not emit ray from all angles, so that it will go in the required direction. So they have that's the essence of using this, because if you use some other material, the particles will still come out of it. So they use this lead container, and they put the radioactive substance inside. And bombard the zinc tin gold foil. This is the tin gold foil with a narrow beam of alpha particle, with a narrow beam of alpha particles, and they place close to it a movable zinc sulfide screen, zinc sulfide screen. This movable zinc sulfide screen was a microscope was attached to it. A microscope was attached to it, This was the microscope. So why is it called a movable screen? Because this screen moves around like this to detect what happened to the beam of alpha particle that strikes, whether the alpha particle bounces back to this direction, to this direction, to this direction, to this direction, to this direction. So this movable zinc sulfide screen will be moving around this thin gold foil bombarded by the narrow stream of alpha particles. So what now happened was so mind-blowing that in the course of this experiment, that Giga and Marsden saw that most of the particles pass through this thin gold foil. Most of the particles, good number of the particles, the ray passed through in their path. They did not deviate from their path. Why some deviated at an angle from their path? They deviated at an angle from their path. Why few in a backward direction? Few in a backward direction. This was surprising. You might not know what it means. Now, it's just like what happened here is just like, you see this, my finger, this paper. Let's imagine somebody is holding this paper here, another person is holding this paper here, another person is holding this paper, just like this. And this, my finger, as you can see, is heavier than this paper. So, and even this, my finger, I decided to move it at a very high speed to pierce this paper. Just imagine this paper bouncing back my hand, like pushing my hand back to hit me or away. That was what happened here. This alpha particle that was used to bombard this thin gold foil was relatively much more heavier than electron that was previously discovered by J.J. Thomson. These particles, alpha particles, is very heavy. How come? What now make it bounce back? Is it the electron? So Rutherford, according to him, he said, I remember when my boy Giga ran to me and was saying, Master, we have been able to see some of these alpha particle get back in a backward direction. We have been able to see it. To Rutherford, he said, this was the most incredible things that had ever happened in my life. It's as you can see, I explained it. It's just so incredible that you use my finger that is coming with a very high speed, now bounced back by this tissue paper. Rutherford said it is just like firing a 15-inch shell on a thin tissue paper, and the thin shell bounce back at you to hit you. That's busting out the other side. So it was so incredible. And Rutherford said this must be as a result of a single collision with that substance that bounced it back. So, and after all calculation, now said even at that, this is still not possible unless you take a system with which the high degree of its mass is concentrated at its core. Unless you take a system in which high degree of its mass is concentrated at its center. So that is the only way this can be imagined. And this is where Rutherford gets its nuclear theorem from, that an atom has a large empty space. An atom consists of a large empty space. Hence, that is why most of the particles pass through a large empty space and a center positive nucleus where the mass of the atom is concentrated. To won him a Nobel Prize. Now, being that, which means it is because of the concentration of the mass here, the concentration of the mass of the atom here, that brought about the bouncing back of the alpha particle in the backward direction. That brought about the bounce back of the alpha particle in the backward direction. And also, in addition, to that could also be the positively charged, because alpha particle is positively charged in the first place. If this center is positively charged, you know that unlike charges, and you know that like charges repel. Okay, like charges repel. So it can also be as a result of the charge and the mass of that particle, because of the speed at which it bounced back. So that is how he discovered the nuclear theory. So if you are asked who discovered the nuclear theory, the person that discovered the nuclear theory is Rutherford, because before this particular time, nobody ever talked about an atom having a center nucleus and an electron revolving around the nucleus. And Rutherford now went further to tell us that an atom contains a center nucleus, positively charged nucleus, electron around which electron revolves. An atom consists of a positively charged center nucleus around which electron revolves. And he was able to measure the radius of the nucleus. That is, this is now the model of that an atom has a center nucleus and electron revolves around the nucleus. An atom has a positively charged center nucleus and electron revolves around the nucleus, and the nucleus contains the positively charged center nucleus is termed what we term today as proton. So that was what Rutherford did and how he discovered it. He measured the radius of the nucleus and he said it is what 10 raised to power minus 14 meter, and he also measured the radius of the atom itself. He said it is 10 raised to power minus 10 meter. So this was a mind-blowing discovery, and he won a Nobel Prize. Even though he was able to, or even though he won a Nobel Prize because of this discovery, there was still flaws in some aspect of this discovery. That aspect of electron revolving around there was a flaw there. But the nuclear theory was very, very correct. The nuclear theory that an atom has a center nucleus still stand the test of time, but that of electron revolving has to be modified. In our next video, we'll talk about that. Thank you. God bless you. And if you are in Edo State, you are in Benin City, you're looking for physical glasses, we are in Edo State bypass. We are in Edo State Sapele Road bypass. We at Oka 1. We are close to Belisima Junction. Fruitful Grand Tutorial will be glad to have you being one of us. Thank you. God bless you. We'll see you in our next video. Bye.